Hello, it's Duncan. This week I've been lucky enough to talk with Stephan Janssen, founder of the Devoxx conference empire and author of the Devoxx Genie AI plugin for IntelliJ that we looked at last episode. My experience of what people are now calling chat-oriented programming, conversing with a large language model to help us write code, is mixed. I've had some impressive results, but on average I feel I'm more productive just doing the job myself, rather than trying to persuade a computer to do it for me. Stephan is an enthusiastic advocate of AI for programming, and has kindly agreed to pair with me to help me become a better chatter. I split our chat into parts. This week we look at how interacting with an LLM via its API differs from the web interface that we're used to. I found this very useful to build my mental model of what the language model is actually working with, and how Devoxx Genie can swap APIs in the middle of an interaction. This is promised for using different providers for different parts of the task, a sort of artificial ensemble development, I suppose. Then the screen capture software crashed, giving a natural breakpoint. If you subscribe now, then YouTube will let you know when I publish the next episode, where we fire up the trusty Gilded Rose stock control code base, and Stephan helps the AI help me to do some tidying up.
My window crashed. My browser window.
So, Stephan, welcome to Pairing with Duncan. You have the, I think it's probably an honour, of being the first person to pair with me since I've renamed the channel to Pairing with Duncan. So thank you for
Great.
being my guinea pig.
Yeah.
Stephan, first thing, how do I pronounce your surname?
Stephan.
No, that's your Christian name.
No, Stephan Janssen.
Janssen. And you're from Belgium?
Yes, correct. I live in Bruges.
A lovely city. I'm planning to be in Belgium for Socrates, Belgium, but not unfortunately Devoxx.
Okay.
But you are the organizer of Devoxx.
Well, I'm the founder of Devoxx, and I organize Devoxx Belgium, which is next month from the 7th till the 11th of October in Antwerp. We have about 3,000 Devoxians, I like to call them. And this year, it's all about Gen AI, of course, lots of large language model related talks. I will probably also demo my Devoxx Genie plugin, which I developed for the JetBrains IDE. And yeah, that's basically what I do as a day job now.
Of course, I knew you from the conferences, but it was Devoxx Genie that brought you to the front of my mind. Did a episode last week, installing Devoxx Genie. I found, as I found with other AI things, like they work, but I have to persuade them a lot, and so I'm stuck, I think, not knowing really how to talk to computers anymore. And you are obviously an expert at talking to computers, so pairings on this, I think, will be fantastic. So the first thing I'd like to understand is the chat model, and how. So I think lots of us have used an AI with the web interface, and we chat with it, and it says a thing, and then we say, "No, don't be stupid, try something else." And so we can see this history, and we can see this thing building up. But how does that work when we use the APIs?
Yeah. But maybe let me just do one step backwards, is that the reason why I developed this plugin was that last year at Devoxx Belgium in the opening keynote, Anton from JetBrains, he did a demo of the AI assistant in IntelliJ. And what really frustrated me was that they didn't support any local models, that it's not open source, but also that it's just stuck to one specific model. There was no flexibility. So that's why I really wanted to build my own in open source, which would support both local models and remote models. But even more importantly, but also important, is that I wanted to build something also fully in Java. I mean, I'm a Java developer. I'm not a Kotlin developer, so I might definitely learn some tricks from you. But so I wanted to build it completely in Java. And at Devoxx Belgium last year, there was an API announced and released called LangChain for J. I was already using LangChain in Python before, but there was actually now a Java version. And so what I've done is that I've taken that API as the abstraction layer to talk to all different models. And the beauty of this API is that you can very easily create a language model connection, either locally, like Olama, LM Studio, Llama CPP, etc. I mean, a lot of those local models, I don't know if you know this, but a lot of them, like Jan, LM Studio, and Llama, they actually use underneath the covers Llama CPP. And Llama CPP is actually a C++ implementation. Specifically, it started for Apple Silicon. So it really works very well on Apple machines, on Mac machines. And they all embrace that one for local models. And then, of course, the cloud ones, I definitely wanted to support also Anthropic's Claude, definitely with Sonnet 3.5, which had a very interesting announcement today, which we can come back to later on. But also like Gemini, OpenAI, DeepSeek, Deep Infra. So all, lots of choices there. But the problem with choice is that if you have so much choices, which one do you choose? What is the best one, etc.? And that's already a first struggle for people who start with this. And that's where, the reason why I developed both of them, local and cloud, is that if I'm online, I will use cloud models. And my one model to go to these days is the one from Anthropic, Claude, Sonnet 3.5.
Mm-hmm.
If I'm disconnected, for example, I'm on the train or I'm in a plane or in the car, and often my wife drives and I can then just continue programming, I often don't have internet, so I then use local models. So my local models are really my plan B. It's really more my fallback in my case, in my scenario.
Mm-hmm.
But I know people who use the IntelliJ Devoxx Genie plugin where they only use local models because their company does not allow them to use any cloud-based models. And the reason is obvious, privacy. A lot of these models, cloud-based models, they will use your code. Whatever you send to them, they will use it as training material for their next data set. So it makes sense then to actually use only local models. So that's a bit of the context. Now, to understand how this works is that you really need to understand the way these chats are constructed. And just to be sure, I actually made a small slide deck. If you don't mind, I can show you the slides, which explains visually a bit how they are constructed. It's not too complicated, but it gives at least a context of how this looks.
Please
Let me share my
do.
screen. Okay. So what you need to know is that an LLM chat is actually consists out of 3 parts. And I'm showing you the first 2 parts. The first one is the system instructions or the system prompt. The system prompt actually dictates what the chat's memory will be about, what the chat will be about. So here you can say, for example, you are a Java expert, you know everything about Spring Boot, you should focus on Angular for front-end development, and be precise, make sure you do a step-by-step analysis of whatever is asked, etc. And that's your system instruction. Now, the system instruction is really important because that really sets the tone of how the model will reply. It basically pushes the model in focusing in a certain area of its expertise. Now, the system instructions, that can be really long. I mean, I've seen system instructions like the one from Claude got exposed last week. It is 2 A4 pages long of what the system instructions are, but it also, of course, includes guardrails if it's from a commercial one. For us developers, we don't care about the guardrails unless we want to avoid them. But for here, in this case scenario, if you want to use it for development in your IntelliJ, you would really specify the APIs you're using, maybe even a bit of how it should reply. Should it be like as an analyst, or should it be more as a senior developer and show lots of code examples? Should the code examples be in Markdown or not? Things like that. So this can be really long. I'll show you later on, the IntelliJ Devoxx Genie plugin allows you to edit that system instructions. So I've got a default one in place, but you should definitely, if you like, for example, doing Kotlin development, you should change the system instruction and say, hey, you should use Kotlin as the primary language to do your code examples.
Right.
Right. So that's the system instruction. That can be very long, very precise. And there's books, and there's even a talk about this at Devoxx Belgium, just about the prompting itself. System instruction is done once. Then you have the user prompt. So the user prompt could be, how should I develop this feature? And then if you only say, how should I develop this feature, it doesn't know anything about the context. So what often is done here is that the plugin and other tools will inject a context. For example, it would include the full project in the user prompt. So in the user prompt, we could copy the full project, and then the question could be, please develop me this logging feature, for example. And then the LLM will understand, okay, it knows the system instructions. I need to focus on the Kotlin language. I've received in the user prompt the full project, so it has a full idea of what's happening. This is a bit what RAG does as well. And then it has this question. And so it will then process this basically and give a response. So this is a one-step prompt response. Now, what you need to know, and this is really important, is that people forget that there is a limit of the input of the window context that you can actually send to the LLM, both on local and cloud models. Now, the crazy thing is that last year, the maximum we could send was 4,000 tokens. Now, tokens is a special way to tokenize your text, and a token is on average 3 characters. I will not go in more detail there, but you basically divide your text by 3, and you're very close to the number of tokens that represents.
They're sort of bits of words, I suppose, running the codey things.
Yes. It's very funny because there was a whole meme about Raspberry where you ask OpenAI, how many R's are there in Raspberry? But because it tokenizes Raspberry in 2 tokens, where berry with the 2 R's is 1 token, it does not know how many R's are in that token because it's 1 token, berry. So yeah, that's how tokens currently work. But what is important that you need to know is that last year, the maximum was 4,000 tokens that we could send to the LLM. 1 year later, 4,000 tokens is the minimum that we can send. The maximum using Google Gemini is 2 million tokens. Now, 2 million tokens, that's almost on average 400,000 lines of code. It depends a bit, of course, of what type of code and what type of language you're using. But on average, they say 500,000 tokens is 100,000 lines of code. So 2 million is obviously multiplied by 4. There was even last week, but this has just only been an announcement. We were not yet able to play with it. There was a company who announced a 100 million token window, which is like basically infinity. But that's the input. So what you can send to the LLM is rather big. What you get back, the response, is very small, actually. It's between 4,000 tokens and maximum 8,000 tokens. And the reason why it's 8,000 tokens is really the hardware limitation, because these cloud LLM providers, if they would do 2 million also as output, it would just not scale with the number of users that they have. I mean, if you look at OpenAI, just announced that they have 200 million active users compared to last year, they had 100 million. You know, this hardware needs to be able to tackle this. So this is where, of course, they cut some corners.
But I suppose nobody wants to read 8,000 tokens of answer.
Well, so that's not true, because if my prompt would be, hey, write me an application which does this and that, and you give it a full spec of a project, and I would like to have the full code back as a response, then I don't have to develop anything anymore because it produces everything for me, right? So we're not there yet. But knowing these restrictions, you can actually then play with it, because if you use, for example, Claude, it will return maximum 8,000 tokens, and it will say like, okay, well, this part still needs to be done, and this part still needs to be done. And so what you do is then in the next chat, you actually say, I'll go to the next slide, you actually have a second prompt, the blue one, prompt 2, but the prompt 2 includes also the response from prompt 1 and the user prompt 1, which had all the context in it, right? So that means if I send another prompt, it has all the information, including the response. And then in the second prompt, I can say, oh, so you said like this still needs to develop. Can you show me the code for feature number 2? And then it will return again between 4 and 8,000 tokens with the next part or the next chunk of your project, and so on. And this is basically your chat memory. Using LangChain4j, I've actually made the number of chats in your memory configurable. So if you go into the plugin, you can actually say, okay, I want to have 10 prompts. And this is dependent on, of course, the model you're using, because every time you have another prompt, it adds to the number of tokens that you're sending, so the number of tokens are growing while sending more and more prompts. And at a certain point, you will either hit the maximum allowed number of tokens, like in Claude Sonnet's 3.5, it's 200,000 tokens. So, you could reach that very rapidly. Or if you don't, it might be that it reaches prompt number 10, and then it goes back to prompt number 1 again, because it's like a circular queue, you see? And so that's where if you go like, oh, damn, it lost all the context, it's either because you've done more than 10 prompts and it has overwritten prompt number 1, which had the original context, so that's gone, or you've reached the maximum window context and it's basically not learning anything more because it's full, basically.
So when we chat with an LLM through their API interface, the LLM is itself stateless. Our first interaction is, here's some system instructions, here's my prompt. We get a response back. The second interaction with the LLM is, here are the system instructions, here was my prompt 1, this is what you said about it, here's my prompt 2, now tell me the next thing. And then the third interaction is system instructions, user prompt 2.
Yes.
What you said to that, what I said to that, what you said to that, what I said to that. And eventually, though, we can run out of space.
Yes. And that's where, of course, engineers are creative and they're looking at creative ways to actually make this as scalable as possible. And one way of doing this is to actually summarize the response from the different prompts. So basically, like compressing the number of characters or tokens, basically, that it's comprised of. So that's one technique that our people are using. The other technique, which we can discuss a bit further on, is caching. Instead of sending constantly the system instructs, the user prompts, etc., the server side, or maybe the client side, because there are multiple implementations currently going on, could actually cache already certain key value pairs on certain tiers. So as a result, we don't have to send everything backwards and forward anymore. It could actually be like with a database where you can cache certain data, which is used a lot. And the unfortunate thing about the caching is that it's still so experimental that there's no standardization yet around caching.
So I think of this sort of as session caching when we have web applications. It's a thing that has to be stored on the server. It's context the server can go to in order to know what it's displaying on screen or something about this, but I don't have to send it every time.
Correct.
So one of the ramifications of this is that if I start a model, send the whole project to it, say 40,000 tokens or so, ask a question about that project, it replies. The next time I'm going to send the 40,000 tokens of my whole project again, plus the response, plus the new thing. And so that's going to get expensive quite quickly because I'm going to be paying for all of those tokens every interaction.
Correct. Yes. Now, the good thing is that if you look at the cost per tokens, 1 year ago, it was expressed in, I think it was like 1,000 tokens. Now it's expressed in 1 million tokens, and it's still in decimals. So, we're talking about 0.02 cents, 200,000 tokens. So it's still relatively cheap. And that's why I also added that in the plugin. So what I've done is that I've added all the pricing of all the different models. So you can do a calculation before you send your project. You have an idea of how much it's going to cost you. And it's always less than $1. Of course, Gemini has 2 million tokens. So if you have a project which fits in 2 million tokens, it might cost you $1 or a bit more even. So you just have to watch out with that. But the beauty of this approach, and then I'll switch to the plugin maybe, but what you can do with the Devoxx Genie plugin is that for user prompt 1, you can select, for example, Llama and Llama 3.1, right? So a local provider or Llama, and the model is Llama 3.1. So that's user prompt 1. It goes to Llama, it gets a response. Now, because it's in the chat memory, I can now, for user prompt 2, before I enter my user prompt 2 or execute it, I can switch to, for example, Anthropic and select Claude Sonnet 3.5, enter my user prompt 2. But because I have this chat memory, the Claude LLM will receive also the system instructions and the user prompt and response from Llama in the memory. So that's why you can actually then have one model review another's model response, which is a very interesting dynamic because it all of a sudden creates like this intermodal communication.
As a human, I feel that would be like waking up in the middle of somebody else's conversation and being required to carry it on.
Or it could really be more like pair development or in a meeting room and you have multiple people with different skill sets. And then you can ask the other person, what do you think about what we've set up to now? And maybe go to another person because he or she is a security expert. What do you think about what we've talked about? And so this is like this expertise center where you can actually mix and match certain different models, specialities, and move it to certain adapters. And this is actually what's happening with the next iPhone. So the iPhone will have very small models on device, which are called adapters. And so you have like one adapter which knows everything about the iPhone manual or iPhone documentation. And so there will be a model before that, like an orchestrator, which will say, okay, the question is about how to set up my Wi-Fi for my iPhone. Okay, then I need to go to this model to ask that question. And it will actually load the adapter, execute it, get the response, and then go to maybe another adapter. And you're basically mixing and matching different models, but this is on device.
From the perspective of a user, I found the Devoxx Genie plugin really useful because it has helped me understand the underlying model at the expense, I suppose, of having to choose models, the right model for this job and that job and so on. Are we in a position to look at a code base and fire something up? Okay.
My window crashed. My browser window.
That's good. So you're still here?
Yes, I'm here. So it was just the browser tab that crashed, actually.